Once the span has been defined, you can then define the wires, the catenaries, and you need to do that in order to calculate lots of things. So if we select from the drop down, we go to catenaries, we'll see that there are no wires defined. They are in the image, but we need to define them. Now the most basic way of defining the wires is to do so manually. To do that, you select the plus button on the top, and then select the image. And from within there, what you do is for each wire that you wish to define, you go in and you pick a place on the wire to the left, the center, and the right hand of the span. So if we go in here and we select the wire like so, and then we up the top, we in the menu we go for center, and we go somewhere in the center of the span. And again, to fine tune where the target goes, just hold the finger down and then you can move the target, and then we go to the right and we can just go to the top of that. And if we go back, and this load case, if it's on surveyed, what we'll see is when we go in here and look a bit closer, that we've got a wire that is following the wire that's there. Now we can't see that wire, but if we click the button on the top right, then the line can be toggled on and off, and we can see that the wire is indeed underneath there. So that's how you'd go about modelling each wire. And the yellow line shows where the centre of the span is, so where the maximum sag is. So if we go back, and we could, the other thing you want to do is specify the temperature at which the what you believe the wire to be at. Let's say it's 10 degrees. And the conductor type, if you know what that is. So I'll just pick sulfur. Once the conductor type is defined, then it tells you all the tension of that wire. So here, starting from the top, you've got the attachment height difference, catenary constant, the horizontal tension and axial tensions at either support, and it even calculates the conductor utilization. That conductor utilization, though, that's for the surveyed temperature. So here it is at 4.9%. We can select the load case and change it to snow, for example, and we'd expect that it's gone up to 13.8%. And we're also down here, we've got the sag that's in the span, and blowout if it's a wind condition, and so on. So if we go back from here, and we can see we've got this record that we can click on now, and that will take us back in there. And so we could continue on and define all the rest of the conductors. In fact, I'll just do one more, and we'll quickly go through this one, selecting the conductor on the right hand side this time. So there's left, and I've gone to center, put one there, and then right, and go back. Now what we'll notice when we zoom in on this is that we've got this orange line here now, which is covering that conductor. However, I've just gone and moved it. It's not helpful. So I'll go back and get that redrawn. So if we go in, so what we note is that the orange line isn't actually over the wire. The other thing we note is that the orange line goes past the point of attachment. Now, if we go back, we can see why that is. And that is because this offset attachment here, really we need to correct for that. And so the attachment is actually about 1 meter to the right of the center of the structure. So if we add 1 meter in here, in fact it should be -1 because it's closer to us. And we can see that now the end of the conductor is much closer to where the attachment point is. I'd say it might be negative 1.2, and that's probably about right. So if we click in here, and we'll see that yes, that attachment is pretty much spot on, and at both ends. However, as we zoom in, it's still not exactly on the wire, and the reason for that is because we're showing the snow load case. So if we go back to surveyed and click in there, and we'll see it's exactly covering that wire. So that's how you go about manually detecting the wires. However, if we delete these, and we can use this delete button up here to get rid of them, or delete this other one, then we can try automatically sensing the wires. And you can only do this at this point if you haven't already defined some wires. So if we select this wand button here, and we can zoom in on the wires that we're wanting to detect, and use this button up the top here, and then swipe across the wires that we're wanting to detect. And we can see that it automatically does that. Now, this is only the beginnings of this automatic detection that we've got here. What we can see actually, some of these wires are reasonably accurate. For example, the purple one in the middle. However, the yellow and the green one aren't so close, and one of them has been missed. So if you hit the cross button, you can try that again. You can try it multiple times until you get a good result. And it might be that in some cases you only get it fairly close. The other thing that we can do is there's another type. So if we go into settings and we've got general options, we can try for the type 1. And as time goes on, we'll make improvements, and it'll get more accurate. But for many spans, by using the automatic detection feature, it'll be a very quick way of detecting the wires. So that's yielded a much better result. All the wires are exactly on, however it has still failed to pick up one wire. And in that case, what you might do is you might go in and do that one manually. So, and yeah, when you go back, you have to select what type of conductor it is. And that does them all, so you may have to retrospectively modify some of the wires if they're not all the same conductor type. But even if some of the wires are slightly out, you can adjust them here. So that's how you go about specifying the conductors.